Welcome, I'm Thibault Marchand. I am Deputy Head of the In Vitro Department in Sederma. So you are now in the In Vitro laboratory. Here our main activity is to prove the efficacy of our products. To do so, we will follow a logical process. And this process begins with the screening step. In the screening step, all new coming products which came from chemistry, pure molecule, genetic resources like plant cell extract, microorganism cell extract, plant cell culture come in our lab, and we have to select the one that can be sold. To do so, we will pass these products on 30 well-known key activity, and depending on positive hit we will obtain, depending on the good stability of the product, depending on this good solubility, and depending on this non-toxic effect, it will be selected to enter in the second step, the research step. In the research step, the studies are done depending on the results obtained in the screening, of course, but also depending on the marketing claim. The main difference with the screening is that here we'll give to the product as much as possible of added value by explaining its mechanism of action by using innovative tools, innovative technology, innovative targets. It's what we call the valorization. And it's very important for Sederma because it allows us to stand out in a very competitive marketplace with upscale products. So in the lab, we are around 20% divided in 5 different groups. All groups are able to work on all types of cells of the skin and on all skin models. This allows us to cover all the field of research in cosmetics. For example, for an anti-aging product, we will look for the dermis and the fibroblast. For a product that will enhance the barrier integrity or a moisturizer, we will look in the epidermis with the keratinocyte. We can also work with special cells called the melanocytes to look for pigmentation in the epidermis. And last but not least, we can also work in the epidermis with the adipocyte to look for sliming product, for example. So this is what we call 2D models. We also developed 3D models under the name of skin engineering. So we have equivalent skin models. Starting from few cells, we are able to create full skin models, which is very customizable. We can do an aged skin, we can do a pigmented skin, we can do a skin to look for pollution. It's a very versatile tools. We have also the skin explant culture, so we receive waste from plastic surgery and maintain them in culture from up to 10 days, and we can apply on top of them a cream, for example. So it's very interesting, and it makes the link between the ex vivo and the in vivo. So it's very interesting because we are very close to reality. More recently, we have developed hair studies. So hair studies to look for two main ways, to look for hair growth and to look for hair pigmentation. So to look for products who will enhance the hair growth or for products who will enhance the hair pigmentation. So this is all our tools or our models, and to work on these tools and these models we use specific techniques. These techniques are quite the same as those we can find in pharmacological lab or in toxicological lab. We will work mainly on 2 levels, on proteomics levels and on genomic levels. On proteomic, we will work with classic tools like Western blotting, ELISA assay, immunohistochemistry, immunocytochemistry, enzymatic assay, and so on. On genomic, we work mainly with qRT-PCR. But more recently, we try to amplify our way of understanding how our product works, and to do so, we will use very powerful tools. For proteomics, we will use what we call LCMS analysis, and for genomic, we use tools like DNA array or RNA sequencing. So with these tools, we are able, for proteomics, for example, we can quantify and identify from up to 1 1,500 protein at the same time, and for genomics we can, for the DNA array, for example, it's around 60,000 genes at the same time. So with that, you have very huge amounts of data. It's what we call big data. And we have to mine this big data to go to smart data. And this smart data is very interesting for us because it allows us to create a network between all genes, all proteins, and to see with great efficiency how our product works on the cells. So in our intention to be innovative, we also invest in specific tools. So we have invested in high content cell imager. We have invested in a full automated system for genomics, and we are looking for a new one for proteomics. So with that, we will have a very huge amount of data, but also the capacity to treat them and to gain in robustness and efficacy.